Let's think about the graph of this function right here. Y equals, keep it kind of simple, x squared minus 4x minus 5. We're going to use the method of completing the square to convert this form right here into a much more convenient form for graphing. So let's try this here. We're going to get y equals, I'm going to write this part here as x as something squared. Now that method of completing the square relies on squaring a binomial. So what do you put in here? Do you remember we did this a few sections ago, actually back in chapter 2. So we take half of this coefficient right here. So it's going to be x minus 2 squared, but then if you kept going, what would you be doing? You square the first, there you go, x squared, multiply these two together, negative 2x, you double it, you get negative 4x, but then if you keep going, you get plus 4. So we're really adding a plus 4 in here. So to keep this thing balanced, we're going to have to subtract 4, and then you still get that minus 5 out here. Let's just quickly run through that again. So I'm going to write these variable parts as the square of a binomial. So I square root or unsquare this, and then I take half of this coefficient. So what happens? You square the first, x squared. Multiply these two together, negative 2x, and double it. There's a negative 4x, but if you keep going, you square the negative 2 and you get plus 4. So by doing this, I'm adding 4 in on this side, right? I'm adding a 4 that's not there. So to keep it balanced, I have to subtract 4, and then I still have the minus 5. So here's where we are now. We're at y equals x minus 2 squared minus 9. So I'm going to circle this because I want to come back to this later. And right now, let's use this form right here and construct the graph. So let's start here with getting the x-intercepts. So we get the x-intercepts by letting y equal 0. So we'll get 0 equals x squared minus 4x minus 5. Let's factor. 0 is, how about x and x? I think we'll have to use a 5 and a 1 with a negative 5 and a plus 1. So it looks like our x-intercepts are at 5 and negative 1. Let's put points there. So I'll put a point here at negative 1 and out here at 5. Now let's get the y-intercept, and we do that by letting x equal 0, right? Because when x is 0, you're going to cross the y-axis. So we'll let x equal 0. So let's put 0 back into these x values, right? I'll take 0, put it here, and that will give us that y is equal to 0 squared minus 4 times 0 minus 5. So we will get the y-intercept to be at negative 5. I'll circle that so I can find it. Now I'm going to put a point here at, 0, negative 5. So 0, negative 5 is right there. Let's put a point right there. And now for the vertex, let's do that right here. The x-coordinate, is negative b over 2a. So let's compute that. So look back over here now at our function right here. So in this case, a is the coefficient of the squared term, b is the linear coefficient, c is the constant. We just need a and b. So just right from here, I'm saying that a is equal to 1, b is equal to negative 4. So the x-coordinate of the vertex is going to be, right, our x-coordinate will be negative b, which is negative 4, over 2 times a, but a is 1. So we get what? 4 over 2, so we get 2. Now, we're going to use that 2 and put it back into the function right here in order to get y. All right, so I'll put 2 right back in here to get y. So we will get y is equal to 2 squared minus 4 times 2 minus 5. So y is equal to 4 minus 8 minus 5. So y is what? Negative 4 minus 5. Y is negative 9. So the vertex occurs here at x equals 2, y equals negative 9. I'll circle that so I can find it. So let's put a point at our vertex. So at 2, negative 9, we'll go over 2, down 9. Let's put a point there. Now we know that a parabola, I'll kind of trace it in here, a parabola is symmetric about a line drawn through its vertex. So I'll draw a line kind of like this, just an imaginary right now, a line through the vertex, and this parabola we know is a mirror image on one side on the other. So I'm going to get another point right here. This right here on this line of symmetry, if I go 2 to the left, I get a point. So I'll go 2 to the right, and that'll give me another point. Just makes it a little bit easier to draw here. All right, we've got enough. Let's just kind of see where we are right now. If we sketch a parabola through these points, we're going to get something that looks like this. Smooth turnaround point. It comes back up through here and continues upward. Now look again at our form up here that we circled in red a while back, and look what information is contained in here. Go down here and look at our vertex. Where's the vertex? Well, it's over 2, to the right 2, down 9. Now look back at this form. Can you see the vertex right in that form? 2, right? If you were to solve this, you'd get, what's going to make this 0? 2 and negative 9, right? Right there at the vertex. So it's very convenient sometimes to write a function in this form right here, and there's a name for this form. This is called the vertex form of a quadratic function. And what do you know? That's what we're looking at right here.